Okay, so I'm gonna do a past AMC 8 test and also just give like tips. So I'm gonna start from the beginning to the end, and then you can like answer in the chat, like whatever question I'm working on. Okay, so first of all, tips for AMC 8. So it's 25 questions in 40 minutes. So that means each question has like under 2 minutes. So if you're stuck on a question, you shouldn't spend like 10 minutes on it. You should just skip it. And if you have time later, you should go back to it. All right, so I'll just start now. Okay, so for number one, you have a rectangular floor. It's 12 by 9 feet long. And you want to find how many yards it is. So, also I'll just write my answers in the side. I might use slide tech. Actually, I probably won't. Okay, so it's 12 by 9. So that's 108 square feet. And there are 9 square feet in one square yard. So this is just equal to 12. So the answer is A. Okay. Oh yeah, that's working. I'll just write A here. All right, so for number two, we have an octagon. And to do this, also I haven't seen these problems before, or I haven't seen it recently. So this is like my first attempt as well. So if we draw these lines, also can you read the question stuff clearly? You can answer in the chat. Wait, I don't know what that, wait, just like say in the chat whether you can read this question clearly, or if I should zoom in. Wait, should I zoom in? Like, would it be easier? Okay. Okay, is this better? All right. Oh, do you want time to solve it? Okay, I'll give you a bit of time to do number two, I guess. Yeah, that works. D, yeah, that's correct. So the way you do it, you draw these lines like this one, this one, this one. So you can see that after drawing the lines, it essentially creates 8 different pieces. And the number of pieces that are filled in, there are 3.5 filled in. So that means the answer is 3.5 over 8, which is 7 over 16. So the answer is D. All right, so for number 3, wait, I'll clear my drawings. Wait, I think after this one, what I'm gonna do is I'm gonna just go through the solutions. I might give some time for like the harder problems, but this is supposed to show like how you work through an AMC8 test. But you can like always put ideas in the chat or something like that. 9 is correct, yeah. Okay, so to do this, use d equals rt. So first you have to convert everything, or not really. So you can write the first equation is 1 is equal to 10 times time. So that means time equals 1/10 of an hour, which is 6 minutes. For the second one, it's 1 equals 4 times time. So time equals 1/4 of an hour is 15 minutes. So 15 minus 6 is 9. So the answer is D. All right, so I'm just gonna go through this like a bit quicker now. Okay, so there's a chess team, and in the chess team, there's 2 boys, 3 girls, and they want to take a picture, and there are a bunch of conditions. So let's draw these 5 spots. In these 5 spots, so there are 2 boys, and they want a boy in the beginning and the end. Oh, and then there's just the 3 girls in the middle. So here, you basically, let's first consider the boys. For the boys, you want to choose an ordering, such ordering of the 2 boys because they're distinct. So you want to choose an ordering of the 2 boys, so there's 2 factorial. And then for the girls, there's 3 factorial. Because the positions that they're in, like the 3 girls, are fixed. However, which girl goes into which spot is different. So this is equal to 2 times 6, which is 12. So I think it's E. Then again, like, I'm not sure about any of these answers, so I'm going to check after the test. All right. So 5. Okay. Number 5, this is basically just testing like whether you know what mean, median, mode mean. So they're already sorted. All right, so let's calculate the mean, median, and mode. Wait, actually, wait one second. Okay, let's think about, so it's asking which of these will show an increase. So let's first consider like the range. The range won't increase, or the range will increase. Okay, so the range will increase because 40 is going to be in the beginning. And the range just means the difference between the biggest and the smallest. So in this case, the smallest gets smaller and the biggest stays the same. So that means the range will increase. So the answer is A. If you have any questions, just ask. Okay, so for number 6, we have a triangle. And in this triangle, it's an isosceles triangle. Okay, so this is 29. This is 29. And this is 42. And you want to find the area of this. So the way you do it is let's drop this perpendicular. This is an isosceles triangle. So this is 21. And this is 21 as well. So in another class, I talked about Pythagorean triples. And we notice a Pythagorean triple here. And it's 20, 21, 29. Basically, what this means is that 20 squared plus 21 squared is equal to 29 squared. So you can also just use the Pythagorean theorem. But this tells us, wait, I did this wrong. Did I? What's that? Just kidding, I didn't. Okay, so yeah, 21 squared plus 20 squared equals 29 squared. So by the Pythagorean theorem, the height must have length 20. And now we can just use the area formula. So area equals 42 times 20 over 2, which is 420. So the answer is B. Okay. Number 7. For number 7, there are 2 boxes. Okay, they each have 3 chips. 1, 2, 3. Okay, so basically, you choose a number, either 1, 2, or 3, twice, and you want to compute the probability that product is even. All right, so this is done by constructive or complementary counting. So the probability of even is 1 minus the probability of odd. So why would we do this? So it's easier to create like a scenario or create what when it's odd. The reason for this is because an even times an odd is even times even is even, but only odd times odd is odd. And the probability of 2 odds is that whatever, 1 minus 2/3 squared. And this is 1 minus 4 over 9, which is 5/9. So the answer is E. This can also just be done by listing out all the possibilities. So when it's even, you can just write like, wait, this is annoying. So when it's even, you can just write like 1, 2, 2, 2, 2, 3, 2, 1, 3, 2. Wait, yeah, 3, 2. These are all the possibilities, but it's really easy to screw this up. So it's better to do it like with complementary counting. Okay. I'll let you do number 8. Like I'll give you a bit of time to think about it. Okay, so I'll just go over the solution now. So this uses the triangle inequality. So in a triangle, this has length 5, this has length 19, and let this have length x. So what the triangle inequality says is 5 plus 19 is greater than x. So this means 24 is greater than x. So the maximum value, wait, that's it. Okay, so the maximum value of x is 24. And this means the maximum value of the perimeter is just 5 plus 19 plus 24 equals 48. And this is D. And notice that this is not achievable, which makes it greater than any perimeter. Because 24 can't actually be x. It's simply greater than all other x. Okay, number 9. On her first day of work. Okay, so Janabelle sells 1 widget on day 1, 3 widgets on day 2, 5 widgets on day 3, etc. So essentially we want to compute this value. 1 plus 3 plus 5 plus all the way to 39. And we can confirm that this has 20 terms. And for each one, it increases by 2. So this is a pretty well-known formula, and it's equal to 20 squared, which is 400. So this formula basically says sum of first n odds is equal to n squared. Yeah, David said 400. So the sum of the first n odds is equal to n squared. The way you prove this is, it's a bit more advanced, but you can use induction. We might cover that sometime. Or there's a geometric proof. Wait, let's see if I can just find it really quick. It's a proof without words. And it's like an illustration. Okay, I think it should be here. Yeah. So the sum of the first n odd numbers is n squared. And the way you see this, so the first way you show this is there's 1 in the first row, 3 in the second row, 5 in the third row, etc. Now let's consider tilting your head like 45 degrees and looking at this again. If you do that, you see it's like a square, and that has n squared. Hopefully this like makes sense, like the proof of this. There's a better animated one. Maybe it's here. Never mind. All right, so basically, this is just a test of like a formula, whether you know it or not. And if you don't, the way you would solve it is probably test small values. Like you replace 20 with smaller numbers, and then you find an answer. Okay, how many integers between 1000 and 9999 have 4 distinct digits? So let's write it as 4 underscores. Okay, so the first has, okay, so the first digit has, it can be from 1 to 9. So 9 possibilities, 1 to 9. Then the second digit is not equal to the first one. David, yeah, that's right. So the second digit is not equal to the first one. So it can be anywhere from 0 to 9 though. That means there are 10 values except the first one. So this is 9. We can continue doing this for the third and the fourth digit. So it's 9 times 9 times 8 times 7. And this is 648. Okay, this is 648 times 7, which is 7, 5, or 6. Wait, I'm really bad at mental math. 4, 4, 4, 5, 3, 6. I think that's 4, 5, 3, 6. Wait, one sec. Let me switch it up. Yeah, it's 4, 5, 3, 6. This is B. Okay, so for number 11, so you have license plates and it gives a something that the license plates have to follow. And okay, so it's 4 digits long. So let's just have like underscores again. The probability that the first one is correct is the first one has to be a vowel. So it's 1/5 times 1/21 times 1/21 times, and the fourth one has to be a digit. So 1/10. This is like constructive counting, which we covered earlier, I think 2 classes ago. Except in this problem, it's probabilities, but it's the exact same idea. And this value is equal to 1/22050. I think so. I think it's, wait, let me just multiply it out real quick. Yeah, it's 22050. So this gives the answer B or A. 12. I'll give you a bit of time to solve this one. Wait, 12 is, I don't think that's correct, but that's close. So the idea is that, let's look at these 4 edges. If we choose any 2 of those edges, those 2 are parallel. Similarly, wait, I'll make my, okay. Similarly, if we choose like any 2 blue edges, those are parallel as well. The last one is the green edges. So if we choose any 2 green edges, they are parallel. So we consider these separately. The number of ways to choose 2 red edges is just 4 choose 2, which, and this is equal to 4 times 3/2. 6 ways to choose 2 red. Okay, so this 4 choose 2 is just if you choose 2 red. If you choose 2 blue or 2 green, it's the same. So it's just 6 times 3 equals 18. And the answer of 12 might have come from like 6 times 2, or if you just counted them and you accidentally counted a bit off. Just, okay, I have a cube now. All right, number 13. Okay, so a subset is basically like you choose 2 of those numbers. So you have a set from 1 to 11, and you want to remove 2 such that the average is 6. Why is nobody else talking? I don't know. Okay, so the way to do this, so there are nine numbers remaining, and average is 6. And by the definition of the average, basically the sum of 9 numbers is 54. So now let's consider what was the sum of the numbers before removing 2. So before, it's 1 plus 2 plus 3 all the way to 11, and you can compute this to be 66. Therefore, the sum of the two numbers is 12. Let's take an example. If we remove, say, 10 and 2, then the sum would be 12, and the average would be 6. So how many ways are there to choose this? So a subset is ordered, I think. So this basically means it can be 1, 11, 2, 10, all the way to 5, 7. And this means the answer is 5. Yeah, so the way you could tell it's 5 is if we just look at the first element. It goes 1, 2, 3, 4, 5. So there's 5. Okay, 14. Also, during the real AMC 8, like if you get stuck on any of these, you should just skip it. Because like if we look later, there are probably some easier questions. Okay, so 14, which of the following cannot be written as a sum of 4 consecutive odd integers? Okay, so this is a bit trickier. The way you do this is 4 consecutive odd integers for even number x, this would be equal to so I wrote this equation. Basically, we set x to be the middle number. And this is not like any of the numbers, but it's like the average of all 4 numbers. The reason why we do this is so it like cancels out. So therefore, this has to be even as well. So it must be divisible by 8. Now let's check which of these is not divisible by 8. We notice 8 does not divide 100. So it's D. This is a bit more tricky. So just feel free to ask. Like you can ask into the public chat or you can message like me. Okay, 15. So there are 2 issues in a school and they're voting. So 149 for the first one, 119 for the second one. All right. So let's draw a Venn diagram. Okay, so in this Venn diagram, the left is issue 1, the right is issue 2. And then 29. Yeah, this is like voted in favor of 1 and voted in favor of 2. So you want to find this middle part right here. And to do that, we notice that this is a pretty common idea called PIE, PIE, which is like principle of inclusion and exclusion. So the way we do this, let's label this like A, B, C. So now we can write that, oops, whatever. Okay, so we can write that A plus B equals 149, B plus C equals 119, and A plus B plus C plus 29 equals 198. So you should see why this, like try seeing why this works. So 149 comes from everybody in circle 1, including the intersection. So we want B. We want B. Therefore, what we do is we don't have to compute like A, B, or C. If we add the first two equations, and just do some computation, we get this equation just from adding those two. And then also A plus B plus C equals 169. So as a result, we can just subtract the first equation and the second equation. Now subtract. And this gives 268 minus 169, which is 99. So the answer is 99. And that's D. Also, just a note, I started this at around 5:05, so I have like 10 minutes left. I mean, this is definitely different than a real test, but like, just for reference, like how long a test is. Okay, a middle school mentoring program, a number of the basically sixth graders and ninth graders are getting paired. Let there be, okay, so the way you do this is let there be A, ninth graders and B, sixth graders. Then 1/3 times A is equal to 2/5 times B. And basically multiplying by 15, we get 5A. 5A is equal to 4B. So we have a relation. Okay, yeah. We have a relation between the number of ninth graders and the number of sixth graders. So what we can do now, wait, I think I messed up. Oh, sorry, this is 6B. Right? If 1/3 of the ninth graders, okay, so 5A equals 6B, then the sixth graders are paired with the ninth graders. Wait, I definitely screwed this up. Does somebody want to find my error? Or should I skip this question? You know what, let's pretend this is a real test and let's skip this question. And something smart to do now is like, let's look through the rest of the test and see if there are any questions we can do more easily. Okay, let's do this one. 18 seems approachable. So first, what we note is basically these are all arithmetic sequences. This is not like a magic square. So those 5 numbers in the first row are an arithmetic sequence. And it's the same for like all 5 rows, all 5 columns. So this value we can write this as average of 1 and 25, which is 13. And similarly, we can write that for the bottom as well. This is the average of 1781, and that's equal to 49. Then, this middle row is an arithmetic sequence as well. So what we can write is x's average of 13 and 49, and this is equal to 31. So that means the answer is 31, which is B. And like this took us a lot less time than if I tried to solve number 16 or 17. So we have 18 is B. Okay. Oh, so this is, I introduced a very useful formula called shoelace a few days ago. And let's first go over this, like probably the intended solution, which is not the shoelace solution. The intended solution is to, oops. Okay, actually, I think we're gonna do the intended solution. So the intended solution is to draw these lines. Then we want to get rid of those triangles on the side. I'll color them green. So we want to get rid of green. That's good enough coloring. And let's take the total red first. So the total red is 3 times 5 equals red was 15. Okay, so red is 15. Then green is, well, let's just add them together using the area formula. So we just apply the area formula a few times. And this is 3 over 2 plus 3 over 2 plus 4, which is 7. That means the triangle is, oh shoot. Did I mess up again? 1, 2, 3. Wait, actually the red is 12. So red is 12. Wait, that means I still messed up. So we're getting that, oh wait, I'm bad. So the total, okay, so that means the triangle is 12 minus 7 equals 5. And also total equals 30, so 5 over 30 equals 1/6. So it's A. And that's the answer to 19. We don't have that much time left in this mock, not in this class, but I might let you guys out early. Because why not? Okay, this seems annoying. This seems annoying. This seems, annoying. Wait, actually, I think we can do this one. Okay, so the way you do it, actually, I'll let you guys think about number 21 for a bit. Equiangular means all the angles are equal. Also, you don't have to like share only answers in the chat. You can also just type like some thoughts. Okay, so the way you do this, let's look at angles. So this angle is 120 because a hexagon has 6 angles of 120. Then in this square, this angle is 90. And lastly, this angle is 60. So now what we can write is 21, or for number 21, angle KBC is equal to 360 minus 90 minus 60 plus minus 120. So KBC is equal to 90 degrees. Oh yeah, 90 degrees. That's pretty nice. Yeah, it's equal to 90 degrees. And also, we know that this length is square root 32. Wait, I can't even write it. So I'll just type. Okay, so we can also write that EF is equal to the square root of 32. And this basically means that BC is also the square root of 32. The reason for this is it's just a property of equiangular hexagons that opposite sides are equal. So then AB, we also know that JB, which is equal to BK, is equal to square root 18. Oh, why isn't this one? Okay, so this means the area of KBC is equal to the square root of 18 times the square root of 32 over 2. The rest is just some manipulation with what's it called? Radicals. So this is equal to that. So the answer is 9. So that means it's B. And this was significantly harder than the other problems we did. And that makes sense because it's later. All right, so that's basically all the time we would get in a real test, even though that was definitely different. So let's look at the rest of the questions. Yeah, they look too hard, except we recognize this one. And this turned out to be a very difficult problem. All right, so now let's go over the answer key and see how we did on this test. Okay, so A, D, D, E, A, B, E, D. Oh, this is D. B, E, D, D, B. Oh shoot, we got 11 wrong.
哇哦，老师把题弄错了，因为都他写的题他都弄错了。
Wait, I didn't write these questions. 我没有写这题。Okay, so wait, that was pretty funny. Nice. Okay, so 14's D, D. We skipped 16 because you didn't want to do it. 18 was B, 19 was A. And oh, I got 26, 21 wrong. Okay, so we got like around 17-ish. But I think if we did it like, oh, okay, Adam. Okay, if we like did it in a real test and we could write stuff down, then I think we would do better. Oh, also, Adam, I'm recording, so I I have a recording of that. Okay. Um, just like, yeah, 17 is a pretty good score, so that's not bad. Yeah, you're gonna be on YouTube. All right. There's nothing else that I really want to show, so like, you can go now. Bye. Oh wait, it was Adam?
Are you still recording?
Oh, I should stop. Um,